Section 9.4, factoring to solve quadratic equations. So we're going to solve quadratic equations by factoring. We've already looked at solving by graphing, so now we're going to talk about solving by factoring using something called the zero product property. And so the zero product property essentially says that when you factor something out, you can set each of the factored pieces you can set them equal to 0 and then solve for the variable. So we're adding one step to factoring, which would be setting equal to 0 and then solving. So here I've already given you a factored quadratic, and all we have to do is the last part, the zero product property. So all we're doing is we're setting each piece equal to 0 and solving. So we've got x, I'll go x minus 7, I don't need the parentheses anymore, and we've got x plus 2. So we're taking each of the factored pieces and setting them equal to 0 independently and solving each separately. So on the left, we're going to solve by adding 7 to both sides, and one of your answers is just a positive 7. In the other half of the equation, we'll subtract 2 from both sides, or the other equation, we'll subtract 2 from each side, and we get x equals negative 2. So our answers here are x equals 7 and x equals negative 2. Same idea here. We just want to set each factored piece equal to 0. In this case, it looks like they factored out a GCF of x. So you've got x times x minus 2 equals 0. So set each piece equal to 0 and solve. Well, in this case, the x equals 0 part's already done. There's nothing you can solve there. So it's just x equals 0. And then the other equation, you're going to add 2 to both sides. And you're going to get x equals a positive 2. And you're done. So x equals 0 and x equals 2. Continuing with the same idea, we've got two factored binomials here, and we're going to set them equal to 0. So we've got 3x plus 4 equals 0, and 2x minus 3 equals 0. We're going to solve each of these. So on the left one, we're going to subtract 4 from both sides. First, we get 3x equals negative 4. Then we divide by 3. That gives us x equals negative 4 thirds. So there's one answer. Then we solve the one on the right. We'll add 3 to both sides. So 2x equals 3. Divide by 2. X equals 3 over 2. So our two solutions are x equals negative 4 thirds and x equals 3 over 2, or 3 halves. You can put these in decimal form if you want. I prefer fractions. All right, so if a quadratic equation is written in standard form, ax squared plus bx plus c, then to solve the equation, you need to factor before you can use the zero product property. So we're going to look at examples where we have to factor first, then use the zero product property. So in our first example here, we've got x squared minus 6x plus 8. We don't have a leading coefficient, so this is the quick factoring one, where we're just looking for the factors of c that add up to be b. So we need them to multiply to be 8 and add up to be negative 6. Well, I know that this is going to be negative 4 and negative 2. So I create my two binomials, x minus 4 and x minus 2. I'm going to set each equal to 0 independently. And then I'm just going to solve. So here I would add 4 to the other side, and I would get x equals positive 4. On the right one, I would add 2 to both sides, and I'm going to get x equals a positive 2. And these are my answers. So I've got x equals positive 4 and x equals positive 2. The next example is very similar. We're looking at a quadratic with no leading coefficient, or our leading coefficient is just 1. All right, so in this case, we're going to do the quick factoring. So we've got 36, and they need to add up to be negative 12. So two factors that multiply to give you 36, but add up to be negative 12, negative 6, and negative 6. So I've got p minus 6 and p minus 6 equals 0. I'll set them each equal to 0, but they're the same quantity, so I really only need to solve one. And so in this case, I will add 6 to both sides, and I get p to equal 6. This time we're going to try something a little more difficult. We have a leading coefficient out in front that's something other than 1. In this case, it's 2. We've got the quadratic 2y squared plus 3y minus 9. So we're going to factor this using slide divide factoring, and then we'll solve using the zero product property. So I'm going to slide the 2 back. So I've got y squared plus 3y minus 18 equals 0. Now I want to factor y squared plus 3y minus 18. I'm looking for the factors of negative 18 that add up to be a positive 3. Well, that's going to be a positive 6 and a negative 3. So I've got y plus 6 and y minus 3. My next step would be to divide by my leading coefficient, so we'll divide both factors. And remember, if it divides evenly, go ahead and divide. If it doesn't, you bring your denominator back out in front. So you've got 2y minus 3 equals 0. So our factored form becomes y plus 3 times 2y minus 3 equals 0. Now our last step is to set each factored piece equal to 0 and solve. On the left, we're just going to subtract 3, so we've got y equals negative 3 as one of our answers. On the right, we've got to add 3 over first, so we get 2y equals a positive 3. Then we divide by 2, and we get y equals 3 over 2. You can also say 1.5 if you want, but these are our answers. All right, let's try another one like that. We've got a leading coefficient of 5 here, so we've got to use slide divide factoring. And so we're going to take our coefficient of 5, and we're going to slide it back through multiplication. We've got m squared plus 19m plus 60 equals 0. Factors of 60 that add up to be 19, well, that's going to be 15 and 4. So m plus 15, m plus 4. In both cases, we want to try to divide by 5. And so 15 divided by 5 is 3. So I've got m plus 3. Here, the 5 doesn't divide evenly into 4, so I bring it back out in front. I've got 5m plus 4 equals 0. Now I just have to set each piece equal to 0 and solve. So m plus 3 equals 0, and 5m plus 4 equals 0. And now I just need to solve. On the left, I'll subtract 3 from both sides, and I get m equals negative 3. On the right, I'll subtract 4, so I've got 5m equals a negative 4. Divide by 5, I get m equals a negative 4/5, or a negative 0.8. All right, so the last part of this that we're going to talk about in the notes is still using the zero product property. The only thing we have to be aware of is to make sure that your quadratics are in the right form. So sometimes it becomes necessary for us to rearrange the items so that they appear in the form ax squared plus bx plus c equals 0 first. So in the next example, you can see we have x squared plus 4x equals 21. Well, this is supposed to be set equal to 0, so something's wrong there. Well, the 21 is on the wrong side. It's our c value, but it needs to be moved. So we'll start this problem by subtracting 21 from both sides. And so that changes our quadratic into x squared plus 4x minus 21 equals 0. Now we can factor this. Our leading coefficient is 1, so we're going to use the easy factoring, where we look for factors of c that add up to be b. So factors of negative 21 that give us a positive 4. Well, it's going to be 7 and negative 3. So we set this up as x plus 7 and x minus 3 equals 0. Now we're just going to set each piece equal to 0 and solve. In the left, we're going to subtract 7 from both sides. So our answer becomes x equals negative 7. on the right, we'll add 3 to both sides, and our answer becomes x equals 3. Same idea here. We are supposed to be set equal to 0, but we're not, so we need to move the 54 to the other side. So I've got b squared minus 3b minus 54 equals 0. The factors of negative 54 that add up to be a negative 3, well, it's going to be negative 9 and positive 6. So right now I've got b minus 9 times b plus 6 equals 0. Last step, set each piece equal to 0 and solve. In the case of the left equation, we'll add 9 to both sides, and you should get b to equal 9. In the case of the right equation, you'll subtract 6 from both sides, and you get b to equal negative 6. These are your two solutions. All right, last example, same idea. We need to get the quadratic set equal to 0. So I'm going to move the 16 by subtracting it. I've got 3g squared plus 8g minus 16 equals 0. We have a leading coefficient greater than 1, so we're going to use slide divide here. So we take the 3 and we slide it back. And so that changes our equation into g squared plus 8g minus 48 equals 0. The factors of negative 48, they give you a positive 8. Well, that's going to be positive 12 and negative 4. Both cases, we want to try to divide by our leading coefficient of 3. If it works, we go ahead and divide. So we'll get g plus 4. If it doesn't work, we bring our denominator back out in front. So then we get 3g minus 4. All of that equals 0. The last step is going to be to set each of these equal to 0 and solve. So here I've got g plus 4 equals 0. I'll subtract 4 from both sides, and I get g to equal negative 4. On the other hand, I've got 3g minus 4 equals 0. I'm going to add 4 to both sides. I get 3g equals positive 4. Divide by 3. I get g to equal 4/3. And so my solutions are negative 4 and positive 4/3.